Welcome to today's video on irrational numbers and percentages. By the end of this lesson, you should be able to explain what is meant by an irrational number, convert a fraction into a percentage and a percentage into a fraction, and compare percentages and calculate the percentages of given values. You are also expected to be able to calculate and use a percentage increase or decrease in a problem, and we'll look at analysing some COVID case data to provide calculated percentages and look at the increases over time based on real-world data. To start off with, an irrational number is a number that cannot be written in the form a divided by b, where a and b are integers. So it's really just a number that does not convert into a nice fraction without some stuff left over, or just a whole bunch of decimal places. An example of an irrational number is the square root of 2. If you put that in a calculator, it'll give you something like 1.41421356. You can see how it is not terminating, as we've seen before, but it's also not recurring. There's no pattern here. It's just continuing on. If we were to try and convert that into a fraction, we would say that 99 on 70 gives us 1.412857. It's very, very close, so we could say that it is approximately equal to the square root of 2, but it is not exactly equal to. Another example that we'll look at in this module is pi, which is equal to 3.14 and then a huge amount of decimal places, again completely random. There is no way to express that or convert that into a fraction. If we look at all of the rational numbers and now the irrational numbers, this is what makes up the set of all real numbers. And if we put this on a number line, we now have the rational and the irrational, both in the positive and the negative, and this makes up all real numbers, all the possible numbers that are available to us. If we now look at decimal representation of irrational numbers, previously we've seen that a rational number can either be terminating or recurring when we convert it into a decimal place, and the decimal representation of an irrational number will neither terminate nor recur. This is what we saw up here. It's not terminating because it goes forever, and there's no pattern here. It's completely randomized. So as we saw, an example is pi, and pi has infinite digits. There's a whole bunch of things out there of people counting or recording pi up to 1,000, 100 decimal places, but it never actually ends. Looking at converting into percentages. When we say percent, it actually means per centum, or it's short for the word per centum, loosely translated from the Latin word to mean 1 in every 100 or in every 100. So when we say a percentage, it's actually just the same as dividing by 100. So some percent of x is x divided by 100. 100% is 100 over 100, which is the highest possible number. It's 1, so that's why we say 100% is the top score. It's the maximum value. If we want to convert a fraction into a percentage, we just need to make the denominator 100. So we multiply it by 100%. If we multiply anything by 100%, we're timesing it by 100 over 100. So therefore, if 100% is 100 over 100, it's equal to 1, we're actually not doing anything to the function. If I times 2 by 1, I haven't changed it. So it's actually okay to multiply things by 1 as we go through. Let's look at an example. Here I've said to convert 3 on 5 into a percentage. So all I do is I say 3 on 5, I times it by 100%, which is 100 on 100. I get 60% here. In this example, it's not super clear how we've done this, but one way to think of it is I need to make the bottom of this fraction 100. And so I would think about what factor or what multiple do I need to times the 5 by in order to get it to 100. And if you go through your head and go, 10 5s are 50, so I times it by 20, and I'll get 100. So if I times the bottom by 20, I need to times the top by 20 in order to not really do anything. 20 divided by 20 is 1, so I've again multiplied by 1. So now if I say the top is 3 times 20, then I work out what that is. 3 times 20 is 60. 60 on 100 is equal to 60%. So that's where it comes from there. If I look at a decimal place here and I want to convert, all I need to do is multiply by 100% again. So in a decimal case, all I do is I move the decimal 2 places because I'm timesing by 100. So I go 1, 2, and I get my 4.2% there. So decimal to percentage, which we'll look at, you just shift the decimal place 2 spots to the right because I'm timesing by 100. For fractions, I want to change the denominator to 100, and then whatever is equivalent on top when I've done the same thing, that is my percentage. So we'll do the same thing here. I've got 1 on 6. I want the 6 to be 100, so I need to figure out how can I convert 6 into 100. In this case, it's a little bit trickier because 6 doesn't go into 100. If you tried to do that into your calculator and you did 100 divided by 6, it'll give you 16.666666 recurring. So I can't actually use this trick. One way I could think about it is I could convert it into a percentage but keep it as a fraction, so I can have a fraction percentage. And that's kind of what we've done here. They've said 1/6 times 100% gives me 100 on 6%. So really I've kept the percentage sign here. And I get 100 on 6%, and then I've converted it to a mixed fraction. I've just gone 6 into 100, 16 times, and I have 2/3 left over once I simplify. So 16 and 2/3% is one way to do it. Otherwise, if I wanted to do it as a decimal percentage, I could just say 1 divided by 6 times 100%, and I could enter my 16.667 or however many decimal places you want to use, and 16.66 could be my percentage. It's not exact though, that's the problem here, and that's why they've kept it as a fraction, because this is now an exact number. So this is exactly the percentage of 1/6. If I go 16.666 and call that a percentage, it links back to the problem we saw earlier where this is not an irrational number. It's not a rational number, sorry. So therefore it cannot perfectly be converted into a decimal place. Have a go at these questions highlighted, and what I'll do is in 5 seconds, the answers will appear. So pause the video now, work through these solutions, and then the answers will pop up. Now we're going to look at converting a percentage into a fraction and a decimal place. So if we want to convert a percentage into a fraction, we divide it by 100%. We go the other way. If I want to make a percentage, I times by 100. If I want to convert a percentage back, I divide it by 100. So I do the opposite thing. And when we're talking about 100% here, not just 100. To show you an example here, if I'm expressing 115% as a fraction, I go 115% divided by 100 because I'm dividing by 100%. So 115 divided by 5 as my common factor gives me 23 on 20 as my fraction. Here, if I had 12.5%, probably the first thing I want to do is convert that to an improper fraction because it's easier. And then I divide by my 100 here because that's my 100% process. So divide by 100, I simplify out the 25 and the 100 here because all I've done is I've converted divide by 100 into a multiplication. So I've reciprocated this, 100 on 1, flip it, 1 on 100. Simplify 25 and 100. 25 goes into 25 once, 25 goes into 100 4 times. I get 1 on 2 times 1 on 4. That gives me 1 on 8 as a fraction. If I want to convert a percentage into a decimal, I can just shift the decimal place 2 spots to the left. So remember when I went the other way, when I convert a decimal into a percentage, I shifted it to the right 2 places because I was multiplying by 100%. Now if I want to convert it to a decimal, I shift it left because I'm dividing by 100%. So an example here is 88%. Remember that would be 88.0. So I shift the decimal place 2 because I'm dividing by 100. 88% is 0.88 as a decimal place. 116, same thing, decimal places here. I go 1, 2, 1.16 is my decimal place. Try some of these questions here where we're converting, in this case we're converting the percentages as fractions, and now we want to convert them as decimals. So go through the process that we've done before. Answers will be up in 5 seconds. Now what we're going to look at is comparing quantities using percentage. So this means something like finding the quantity as a percentage of another thing. So saying that you increased your money by 20%, rather than just saying you increased your money by $2.50 or whatever it is. We're using a percentage to make a claim. So an example here could be to say Mike ran 10 kilometers out of 50 kilometers. What percentage did he run? So 10 out of 50 as a percentage. Rani spent 5 months of the last 2 years overseas. So what percentage of the last 2 years did Rani spend overseas? So we do it like this. First, we need to get it into a fraction. So 10 kilometers out of 50 kilometers. The out of is basically the same as a fraction or divide. 10 out of 50 is 10 on 50. I want it as a percentage, so I times by my 100%. And using the same process as before, I get 20%. So 10 kilometers out of 50 kilometers is 20% of 50 kilometers. So Mike ran 20% of 50 kilometers. In the next one, we're talking 5 months out of the last 2 years. So 5, that means if we want to go to months, because remember we want the same unit, I can't do months and years. So I need to go 2 years is 24 months, 5 out of 24 months, times by 100%, I get my 20.8% approximately. So this was done with a calculator because it's not exact. So roughly Rani spent about 20.8% of the last 2 years overseas. Have a go at these questions here where they're asking you to express as a percentage from some information, and then this is more of a written scenario. So he's talking about if he's at the cinema, what percentage did he spend on these things? Answers will be up in 5 seconds. Now we're going to look at the percentage of a value. And to find the percentage of a quantity, we convert the percentage into a fraction or a decimal, and then we multiply it by the value. So an example here would be to find 6% of 150 kilograms, and we want to know what actually is that? How much mass, how many kilograms is 6%? And in this case, if you had $210 and I said, give me 4.5%, you want to know how many dollars do I actually need to give you? So the process looks a bit like this. 6% of 150, 6% is 6 over 100, because remember, percentage means over 100. So 6 over 100, of in maths means times, basically. So whenever we hear a scenario that says 6% of 150, 6% over 100, of multiply by, so we get 6 on 100 multiplied by 150. We've just simplified the fraction here. We've divided 100 into 50 and 150 into 50 3 times. We get 9 kilograms. Same thing here. We've changed to a decimal place. So 4.5%, we move the decimal 2 spots backwards. 0.45 times $210 gives us 9.45%. Try these questions out in Highlight where we're converting percentages of actual values. Answers will be up in 5 seconds. Next thing is we're looking at a percentage increase and decrease. So this means rather than just going, what is the actual value if I said 10% of this, I want to know how much is that increase in a percentage. So an example could be that your salary is increased by 15%, the price of goods is increased by 4%, a man on a diet reduces his weight by 10%, or a store has a 25% discount sale. Ultimately, it's very similar to what we just saw, where we're figuring out what amount of something is 4%. But in this case, the scenario is that we're talking about increases and decreases of a percentage. So for example, if we were to say this thing cost $10, it increased by 10%, how much does it now cost? There's 2 steps to that. You need to find out what is that percentage first, and then add it to the original cost, and now you have the final cost. So the method 1 is using 2 steps. This is where we find the size of the increase or decrease, and then we apply it to the change of the original, just like I said before. So figure out what is that value, add it to the original value, you get your final value. So here we go, $5,000 by 20%. So if you had $5,000 and we increase it by 20%, we first need to know what is 20% of 5,000. We go through the same process, shift your decimal place 2 spots, 0.2 times 5,000 is 1,000. Therefore, the amount of money you have is the 5,000 you started with plus the 1,000 that you increased by. You now have 6,000. Same thing for decreasing. We figure out 12% of 80,000, and now we subtract it because it's a decrease from the original value. We get $70,400. Method 2 is using a multiplier. So the original amount is 100% of the quantity. If we increase the amount by 20%, then this is added, and in total we actually now have 120% of the original. If I was to decrease it, I'd do the same thing. I start with 100, but if I decrease by 20%, I now have 80% of the original. So I could do this basically in one step, where I figure out what is the final percentage, which is my multiplier, and then I times that by the original value. So if we look at the same example from 7, increase $5,000 by 20%, I had 100%, I increased by 20%, I now have 120% of $5,000. Now I can just do the same thing. 120% of 5,000. We can convert this to a decimal place. Of means times. 1.2 times 5,000, $6,000. So exactly the same answer. So there's two different ways you can do this. The two-step method is this one, and the multiplier method is figuring out the total percentage first and multiplying the value by it. Have a go at these questions here where it tells you specifically we're using the two-step process to start with. And then in these questions, we're using the multiplier process. Answers will be up in 5 seconds. The next thing we're looking at is percentage change. So this is where we're comparing how much we had to how much we finished with, and we're looking at what percentage the change is. So the opposite of what we've just done. The formula for this is that the percentage change is equal to the change divided by the original amount times by 100%. And we'll look at an example now. If we had $120 and it changed to $150, what is the percentage increase or decrease? We first want to use the formula. We say the final amount, take the original amount, means the change was $30. So we do $30 divided by the original amount, which was $120. We times that by 100%. We get 25% here. So there's a 25% increase. Here we had 400 meters down to 250. The change is negative 150. That means we lost 150 meters. We use the same formula. The change is minus 150 divided by 400. We times it by 100%. And we get negative 37.5%. So the negative implies a decrease. Positive values means it's increased. Negative percentage means it's decreased. Use the process we just talked about and have a go at these questions here. Answers will be up in 5 seconds. The other option is to look at the unitary method. Let's say Bridget and Michelle own a business. Bridget receives 25% of the profits each month, and last month Bridget received $2,080. How can she work out the total profit made by the business last month? The unitary method is used to solve this problem. We first find 1%, and then we multiply by 100 to find the whole amount. So an example of this would be to find 100% of the sum of money if 25% is $2,080. Firstly, we say 25% of this is $2,080. Therefore, 1% is $2,080 divided by 25. We get $83.20 or $83.20. Therefore, 100% of this amount is 83.20 times 100. That means the whole amount is $8,320. You can also use this to find other percentages of a quantity. If 18% of students are in year 8, 16% are in year 9, the school has 126 year 8s, determine the number of year 9 students. So we use the same process. 18% is 126 students. 1% is that divided by 18, which means we had 7 students. If 16% is 7 students times 16, that equals 112 students. Therefore, the school has 112 year 9 students. So it's quite useful if we know a percentage for one thing, not the other, but we know a total number. We can combine the things that we've covered to break this down. It is a little bit complex. Have a practice with these questions here from 3D using this unitary method. So if you need to, you can jump backwards and look at the process again, but try and solve these questions here. Answers will be up in 5 seconds. Going back to our dystopian future analysis, the human body not only requires water to survive, but it is primarily made up of water. This is a table I got from the internet where we're looking at the percentage of water for the average part of the body. So on average, 60% of the human body is water. The brain and heart is 73%. The lungs are 83%. Skin is 64%. Muscles are 74%. And the bones are 31%. Firstly, I want you to calculate how much water your body contains using the 60% value and your body weight if you know it. If you don't know it, you can just make a rough guess and use that value instead. If you're recommended to drink an average of 3 liters of water every day, calculate what percentage of your body weight this is and the percentage increase of water if you drink that 3 liters. If you drink 600 ml bottle of water, what percentage of your recommended amount is that from the 3 liters? And what percentage increase has your body's water just jumped up by? Lastly, a mere 5% dehydration, which is judged by your body weight itself when you weigh yourself, can actually be very severe. Calculate the amount of water that 5% of your body actually equates to, so that you know how much water you would actually need to lose to be at a 5% dehydration rate. This concludes the lesson module on percentages and converting percentages. Good luck surviving out there in the wasteland.